piecewise functions are used when a single expression cannot model a situation. An example of this that you would encounter in everyday life might be your cell phone bill. Most cell phone companies charge a base rate for a certain amount of minutes. So for example, let's say that your cell phone company charges $80 as long as you use 1,000 minutes or less. Well, if one month you use 50 minutes, you're still going to be charged $80. If the next month you use 1,001 minutes, then you're going to be charged $80 plus an additional amount for that 1 minute that you went over. So let's say they charge you 25 cents a minute for minutes over 1,000, so they would charge you $80 plus the additional 25 cents. And so that would be an example of a piecewise function where we need more than one function to describe the situation. For this piecewise function, we can see there's 3 pieces. The notation on the right describes which piece that we would want to use for which x values. So we would only use the top piece if our x values were less than -7. We would use the middle piece only if our x values were between -7 and 1, including the -7, not including the 1. And then we would only use the bottom piece if our x values were bigger than 1. So on here, for the -9 part, if we're wanting to evaluate h of -9, we want to know which piece does -9, which we know is an x value, fall into. So we want to go look at the first piece. Is -9 less than -7? Yes. And so that would mean that you want to use the first function. And so we would want to plug -9 into -4x minus 20. So we'd have -4 times -9 minus 20. -4 times -9 is 36. 36 minus 20 is 16. For each function evaluation that you have, you will have only one answer. So even though your piecewise function has 3 different pieces, for each single function evaluation, you will only have one answer. Whatever you do for these type problems, do not plug your x value into all 3 pieces. That's not the proper way to work the problem. Let's go down to the second part. So in this one, we have an x value of -4. Look and see which piece -4 falls into. Is -4 less than -7? No. Is -4 in between -7 and 1? Yes. And so that would mean I want to use this function. Now that function is just constant. In other words, the y value is 1 as long as your x's are between -7 and 1. So this one, you don't have to plug the -4 into anything. It would just be 1 as the y value. Go down to the third example. We have h of 1. So looking back up, we would want to know which piece 1 falls into. Does it fall into the first piece? Is 1 less than -7? No. Does it fall into the middle piece? Is 1 in between -7 and 1? Well, on this one we have to be careful of the endpoints. We can see that the -7 is included because there's a bar underneath that inequality sign, but that the 1 is not, so it's not in that interval. And then if we look down at the bottom one, we see that there is a bar under the inequality symbol there, so the 1 is included on that one, so we'd want to use that last function. And so we would have 1 plus 9 equals 10 for that one. Okay, and then finally, go try this one on your own. We have h of 3. 3 is an x value. Which piece does that x value fall into? Well, it turns out it falls into the last piece, which is the x plus 9 function. So we would have 3 plus 9 would be 12 as the function value at 3.